So we didn't look at corner competition last week. So we'll start by going through corner competition, and then we'll move on to stuff from the next topic. Okay. So Corno, I know you've done Corno before, but you probably only did it with 2 firms when you did it before. Is that right? You did 2 firm Corno? Okay. So we're going to do n firm Corno, which is not really that much harder than 2 firm Corno. There's just one trick that you have to internalize, and once you know the trick, everything's easy. Okay, so we're going to have an inverse demand curve. Excuse me, I'm quite ill. P of Q. Q is going to be the total quantity produced in the industry. Okay, so each individual firm is going to produce quantity Qi. So we're going to be firms indexed by I. So firm 1 up to n. Firm I produces quantity little q of I. Big Q is total quantity. Okay, so what's the link between big Q and the little q's? Well, big Q is just the sum of all of the little q's. Okay, you know this sigma notation. It's the sum from I is 1 up to n of Qi, which just means Q1 plus Q2 all the way up to Qi. Okay. So don't get confused between big Q's and little q's. Big Q will always be total quantity. Little q is individual quantity. And they're all producing the same product, okay, so the consumers don't care which firm they buy from. Their demand curve is just a function of the total quantity they're buying. Okay, so they might be buying 50 from the first firm, 20 from the second firm. But, all they care about is that in total they're buying 70 units. Okay, so each firm is going to have a total cost function. This is going to be Ci of little qi. Okay, so the costs of each firm are just a function of the quantity produced by that firm. Okay, costs increase as quantity increases because you have to start paying overtime or whatever. But just because you're producing a lot, it doesn't mean that my costs are going to be high. My costs are only going to be a function of the amount that I personally am producing. Make sense? Okay, and the firm is going to make profits of price and quantity minus total cost. Standard. Okay, so price is just a function of aggregate quantity times the individual quantity that firm is producing. Okay, minus cost, which is a function of the individual quantity. So does that make sense, the objective? And this is all in Oshai 6.167. Okay, so let's just go through the duopoly case, which you've seen before, just to remind you. So we've got 2 firms, total quantity Q is going to be Q1 plus Q2. So remember when we're solving for a Nash equilibrium in this game, the game of choosing how much to produce. What's a Nash equilibrium? In a Nash equilibrium, everyone is playing their best response function. Okay, everyone is maximizing their profits, holding fixed the strategies of everyone else. Okay, so imagine that you knew that firm 2 was going to produce some quantity Q2 star. What quantity would firm 1 want to produce? Well, firm 1's profits, okay, our price is a function of quantity times quantity, all minus total costs. Price times quantity minus total costs. So we just have to differentiate that. These are firm 1's profits. So firm 1 is choosing Q1, how much to produce. Well, we've got a product term here. How do we differentiate the product? We use the product rule. Okay, so we get derivative of the first thing times the second. So P dashed, okay, so we're differentiating this. Well, the derivative of P of capital Q is P dashed of capital Q. What's the derivative of capital Q with respect to Q1? It's just 1, right? Capital Q is Q1 plus Q2. So D capital Q, dQ1 equals 1. Okay, so we're using the chain rule to differentiate this. Derivative of the outside times derivative of the inside, but the derivative of the inside is just 1. Okay, so that's easy. So we just get P dashed of total quantity times Q1 Okay, that's what we get when we take derivative of this times that. Now we need this times derivative of that. Okay, well, there's the price term again. And then we need derivative of Q1 with respect to Q1, which is just 1. Okay. And then we get the derivative of total cost, which is marginal cost, C1 dashed. Okay, so there's firm 1. Firm 2 is exactly the same. They have some profit function. Okay, price as a function of total quantity times quantity produced by firm 2 minus total costs as a function of quantity produced by firm 2. Everything's exactly the same, right? Product rule, P dash Q2 plus, okay, derivative of this bit, which is just 1 times that, because it's the price term, minus marginal costs. Okay, so that's all easy. Yeah, okay. Okay, so the trick for doing Corno, the general trick for doing Corno is you take the first order conditions for each firm and then you add all of them up. Okay? Doesn't matter what the Corno problem is, this always works. So you add up all of the first order conditions. Remember, you know, if you've got two equations, if you've got A equals B and C equals D, then you know that A plus C equals B plus D. You can always just add equations together. Okay, so we're going to do this equation plus this equation. So what do we get when we add the two things up? Well, I've done 2 steps in one. Here we're going to get, this is the same, right? P dashed of capital Q, P dashed of capital Q. Here we've got a Q1 and a Q2. So when we add those two things together, we're going to get a capital Q. So adding these two, because there's P dash of Q times capital Q. Here we're going to get P of capital Q plus P of capital Q, which gives us 2 times P of capital Q. Here we're going to get marginal cost for firm 1 plus marginal cost of firm 2. So when we add the two things together and then divide by 2, just to make things a bit neater, okay, so it's just the same thing, we get half in front of this, P dash capital Q times Q. Remember the Q was coming from Q1 plus Q2 here. Okay. Here we get 2 copies of P times Q, so when we divide by 2 we just get P of Q. And then if we take the marginal cost over to the other side, we can have the half of C1 dash plus C2 dash. Okay, so what's this thing on the... Sorry, you have a question?
No, sorry, it's just when you said you added the two together and then divided by 2, well if you've got 2 of P dash Q big Q and then divide that by 2, that's just 1.
Well,
you've got half.
What you've got is you've got P dash big Q times Q1, and then you've got, that's in one equation, and then in the other equation you've got P dash big Q times little q2. Okay, so when you add the two things together, you get P dash big Q of Q1 plus Q2. Okay, and that thing is just big Q. Okay, and then we divide by 2. Does that make sense? Okay, so here's Corno duopoly. What's this thing on the right hand side? Okay, describe this thing in words. Very quiet. So this is marginal cost of firm 1, this is marginal cost of firm 2. Adding the two things together, dividing by 2, it's average marginal cost. Okay, so the total quantity produced is going to be a function of average marginal cost here. And then on the left-hand side, well, this is quite similar to the expression we got under monopoly, right? Under monopoly, right, we have ignore that half, we had P dash times Q plus P of Q equals marginal cost. So this is almost the same as the expression under monopoly, but we've just got this extra term, the half. So rather than working with the marginal cost of one firm, we now have average marginal cost, and we now have a half in front of that term compared to the monopoly case. So having two firms, if you like, this is bringing us closer towards marginal cost pricing, right? If this was 1 over a million, this term would kind of drop out. Okay, then we'd have price equals average marginal cost. Okay, so we come closer to pricing at marginal cost because we've got this half in front of this term. Okay, you'll see it more clearly when we have n firms. So let's do the same thing when we have n firms. So now we've got firms 1 up to n. Think about firm I. Well, suppose that all of the other firms are playing their optimum. Okay, so you know, firm 1 is producing Q1 star, firm 2 is producing Q2 star, etc., etc. Firm I minus 1 is producing Qi minus 1 star. Okay, but we're just concerned about firm I. So suppose firm I is producing Qi. So here's the profits of firm I. Is price as a function of total quantity times quantity produced by firm I minus total cost of firm I. Okay, so we just have to take the first order condition to maximize this. So again, here we've got a product. We've got price as a function of total quantity times Qi. So we need to use the product rule. Derivative of the first term gives us. Is that the thing beeping? Is it still going? Still going?
Yeah.
So to take the derivative of this thing with respect to Qi, well, get derivative of the outside, which is just P dashed of Q, times derivative of the inside. Well, what's the derivative of capital Q with respect to Qi? It's still just 1. Okay, so here we get P dash Q, and then we get the times Qi. So this is the derivative of this times that. Now we need this times derivative of that. Well, derivative of this is just 1. Okay, so that just gives us plus price. And then minus the derivative of this, so minus marginal cost. Make sense? Okay, so we've got this first order condition. Technically we should check second order conditions, and we should check that they're actually making positive profits, so they do actually want to produce anything at all. Okay, not going to worry about that for now. The trick is just the same as before. You have to add up all of the first order conditions across all of the firms. Okay, so we've got these n firms. They all have first order conditions like this. Okay, this is RU, which is 0, 0, and this is RK, which is 2, 1. Okay, that makes sense? So we can put everything in a grid. And remember I showed you that trick for finding Nash equilibria in these games with a grid. You just underline the best responses. So, okay, so if player 1 is playing L, what does player 2 want to do? Well, player 2 can get 1, 1, 3, or 3. Well, they prefer 3, so we've underlined these two 3s. If player 1 is playing R, then player 2 has the choice of getting 1 or 1 here. You can't read that, but this is 2, 1. Okay, so we've underlined these two squares. Then player 1, well, if player 2 was playing KK, player 1 would want to get 3 rather than 2. Okay, 3 rather than 0, 1 rather than 0, 2 rather than 1. Okay, so we've got two squares which have two things underlined. This one with 1, 3, and this one with 2, 1. So there are two Nash equilibria to this game. But one of them's a bit funny. So what's going on in let's look at this one. So in this apparent Nash equilibria, player 1 is saying, doesn't matter what you do, player 2, I'm always going to play you. Okay? But if you get to this point, suppose in the first period player 1 played R, so you're at this point here. Well then, player 2 would have a choice between getting 1 or getting 0. They obviously strictly prefer to get 1, right? So it would be crazy for player 2 to play U here rather than K. So this equilibrium is a bit strange. It involves an impossible threat. It involves player 2 threatening to do something that they would never want to do when the situation arose. Okay, and because they make this incredible threat, then in the first period player 1 is forced to play out. But really, player 1 just shouldn't have believed the threat in the first place. In reality, player 2 is not submitting a computer program at the start of the game. In reality, player 2 isn't making a decision until we get to this point. Okay, and if player 2 ever found himself in this point, he would choose to play K. So, although this is a Nash equilibrium, we say it's not a subgame perfect Nash equilibrium. So a subgame perfect Nash equilibrium just means that at every point at which people are making decisions, even if it's a point that's never actually reached along the play of the game, at that point people are still behaving sensibly, rationally. Okay, so at this point, player 2 is making a decision, but choosing between 1 and 0, they should always choose 1. Okay, anything else would just be crazy, it would be an incredible threat. So they can't commit to do something stupid. So the only subgame perfect Nash equilibrium is this one, which you can't see due to the shitty projector. Okay, so this is 2-1. This is the... What is it? It's RK, so it's here. Okay, so in the first period, player 1 plays R, player 2 plays K. So the black lines, originally there were some red lines. For some reason, red isn't shown. Okay, so this is a red line. These are red lines here. These are red lines here, showing the. It's just the projector's not working. Okay, so if you look at the slides online, this is red, and there's a red bit there. That's showing the play of the game under the subgame perfect Nash equilibrium. Okay, so under the subgame perfect Nash equilibrium, if player 1 plays L, then player 2 plays U. Okay, they've got a choice between 1 and 3, they prefer to get 3. That makes sense. Okay, so here player 2 would choose U. Here, because they've got a choice between 1 and 3, here player 2 has a choice between 1 and 0. Okay, so they would choose 1. So if you like, in the first period, player 1 had a choice between these 2 points, 1, 3 and 2, 1. They prefer 2, 1 to 1, 3. They prefer to get 2. So player 1 will play R in the first period to get 2. Does that make sense? So how have we solved this game to find the subgame perfect Nash equilibrium? Well, we started in the last period. Okay, you start by working out what player 2 will do in the last period. Okay, so here in the last period, player 2 plays U and K. And then, having worked out what player 2 does in the last period, then we can go back and work out what player 1 wants to do in the first period. Okay, so this slide just defines the subgame perfect Nash equilibrium for you. If you haven't seen this before. So I'll just say it in words again. The idea is, at any point in the game tree, okay, whenever anyone's making a decision, even if it's not a point in the game tree that ever actually happens, at that point, from then on, people must be playing a Nash equilibrium. Okay, so people must be playing best responses. And that rules out making these crazy, incredible threats. So all subgame perfect Nash equilibria are Nash equilibria, but not all Nash equilibria are subgame. I'm going to show you this. Okay, so I'm going to describe a game to you, And then we'll take a little break while I go and get some coins, and then we're going to play this game. Okay. Wake you up about. Okay. So we're 2 players, Alice and Bob. So Alice gets to move first. Okay. So at the start of the game, Alice has. She's got 2 piles of coins in front of her. One with 4 coins, one with 1 coin. Okay, and Alice has the choice. She can either take the pile of coins with 4 coins, or take the pile of coins with 1 coin, or she can push the 2 piles of coins across the table. Okay, if she pushes them across the table, then magically both piles of coins double in size. Okay, so pile of coins with 4 becomes 8, pile of coins with 1 becomes 2. Okay, then Bob, if she pushes across the table, Bob has the option to make the same decision. Okay, you can either take the 8, take the 2, or push them back across the table. Okay, if Alice takes, if in the first period Alice takes the 4, then Bob gets the 1. If in the second period Bob takes the 8, then Alice gets the 2. Okay, so if you like, in the first period Alice has a choice between getting 4 now, or pushing across the table and risking only ending up with 2. Okay, so she's might have a bit of incentive to take the money now, but equally, maybe if they can coordinate somehow, maybe they can get a bit more money. So the game continues for a fixed number of rounds, okay, or until someone decides to take the money. Okay? So the question is, how many periods is it going to take before people take the money in this game? Okay, potentially, what's the maximum people could earn in this game? Well, suppose there wasn't this fixed number of rounds thing. Suppose it could go on forever. Well, then people could earn an infinite amount of money. If you just keep on pushing the money across the table, the piles of money keep on doubling, eventually it's going to be infinite. Okay, so what we're going to do after the break is we'll play this for real. I'll be the magic person who doubles the money every time it crosses. Okay, but because I'm putting a lot of money in, you're going to pay to play the game, so I don't lose all of my money. Okay, so if you've got any change, you can bid to play the game. Okay, so we'll have an auction to decide who gets to play the game. So hopefully some of you have got some cash, or hopefully you're being a bit less quiet than normal. Okay, I've got to go and run and get some coins. So we'll take a 5-minute break while I get some coins.
So you're asking why? Yeah. There's no. Where is you cross it out? Even these ones. Huh? There isn't.
It goes like this. K minus B Q minus B minus 1Q plus NK Q minus B minus and 1 over N, so that removes. Then
Yeah, it comes from here.
that's K. Where does the N come from?
So there's no any even at the beginning.
So you've already done NK this long. So 1 over N is
I mean, I could.
K gets NK gets removed. This becomes 1 over N minus 2, which is C bar.
Oh, I know.
So it kisses.
Oh.
So it kisses.
Don't try to snake me. I can crash, don't you worry.
No.
However,
However,
you could,
Say,
there are loads of like,
So I've actually missed one.
like after party. Technically, when you rock out at 4 in the morning, you could kill an hour to 2 hours. Buying your bar and Vauxhall until the train rocks up at Vauxhall to take
So
home.
you're actually just going to snake us?
Oh,
You're not going to allow us to sleep on the car?
no, that's not. That'd be
So wait, if it was just you and Yasmin,
That's how
you
much.
just left it?
No. I would have hopefully thought more people would have gone, you would have done like an account.
Yeah, that was the plan, but I don't know what's Joel doing.
Joel's go back to his
I was like, the one time in my boat I saw a camera.
I guess it's still automatic. I don't know.
Yeah, just that was so weird.
Let's leave Yasmin and ask stuff about the books.
No, so you're actually going to say, if we all go from other teams, it'll be okay.
Oh, then I'm not sure because yeah, we need to discuss it because I'm feeling like my Saturday is completely written off at this point.
Yeah, I've already read it.
I don't have time for that. I don't have time.
Just do loads of work on the Friday. That's what I'm going to do. Like this whole week I'm just going to upload work and then try them to that then coming back to Guildford.
Coming back to Guildford at like 7:30 in the morning. I mean, it's going to be so good, isn't it? You're going to feel so good about yourself.
The thing is that I know it sounds really I don't know after talk I kind of get tired.
I get tired and bored.
Maybe it's that late because it is open till 6.
Oh wait, it's open till 6. I didn't know.
Yeah, but have you like
That's a long time.
yeah.
I'm going to be in Florida. That's 6 hours.
Isn't it like 9?
Well, like 11:30 till 6.
I mean,
That's extremely easy.
that's really good.
We get
Have you ever been? So I don't even know, like, will I even be able to bear 2 hours?
When I dropped out, I had been to like when you come out and you like you didn't realise the daylight started happening.
It's okay, £15 a ticket. I don't even know why I said yes.
Well, I thought, yeah, I support you, Joel, because everyone else is going to come.
Well, the thing is, the first time you did it, I really wanted to go. I was like, yes, I thought everyone would want to go, and I was like, Joel is DJ, so I wouldn't want to go. So no one did, so I was just like, okay, like, me and Joel are not like best buds, so we used to just rock up by myself and be like, hey, good one, bye.
I'm asking now if it's Snake.
I can't believe they would have been, like, I would like, I would have thought, especially because yeah, no,
It worries me. It worries me.
are you right?
Let's see if I can check it. Yeah,
Because the page again. Do you want to tell you how to win again? Yeah. If you go first, like, right there and then.
Depends how much you want to do.
No, because if no matter what you do, like if you pass it on, the next person will take it. Like you'd never know if they're going to take it.
Or if the payout is
less money.
the payout's 2 and you have to put 2 into play. You never know the percentage you get.
No, but if you go first, then you take 4.
No, because it starts 2 and 4.
That's the 2 and 4, so you take the 4 and give the other person the 2. If you wait till the next round, the other person can take the 8 and give you the 2. Does that make sense?
No, because it goes 4 ones and it goes 8 2. So if I push it, let's say I have to put 2 back. And I start with 4 1 and I push it, and it comes 8 2. If I get 2, there's 0. So there's no way I can lose.
Well, yeah, no, so why would you not at the start, unless you're the second one, but at the start you choose the 4 because the other person then you make it 2. That's actually just a bit
Yeah.
whoever goes first.
Well, I think it could technically go to infinity.
It could, but that means you guys need to work together.
Then I thought it would never ever end up going to infinity because I say it really out. Even if it got up to that height, it doesn't really matter the outcome. If you get pushed an infinite amount of times, you know the money's just going to be infinitely lower. I'll take 100 and push. I don't think you'll have this time.
No, but that requires you to have cooperated for that many rounds.
Okay,
That
but
means
either
you have to
way,
agree with
I get get bored and snake him
Yeah.
for £100 and give him 50, or he snakes me for 100.
What's it say you might snake you up? Take 400 and give you 2.
Well, then he didn't think it through, did he?
Well, that's the thing about the game. If there's
I think it's stupid not to do
correct
two.
option you use it could continue
He's going to
going.
fix the rounds, so let's say 3. So then, you take it first round. Yeah, awesome. But then
Even if it wasn't fixed, because you don't know what that person will do. I mean, unless you guys have a proper.
no, it would only be okay if I pushed, he pushed. As long as he pushes again, it goes from 2 to 4, so now I have 16 to 4. From that point onwards, I would at least get, I would get if I took it in the first round. With an opportunity cost.
That's not the way. I mean,
Okay, coins. I saw you all plotting. I hope you're not coordinating to rid me of my money. Obviously, if you collude, you could do quite well after this game. But do you really trust each other? That's the question. In order to collude effectively, you've got to trust that the other person isn't going to screw you over. And, I wouldn't trust each other. Okay, so who wants to play? Who's going to start the bidding of a right to play? Okay, so you're bidding for the right to play. We're playing with 5p's. Okay, I've got £10 worth of 5p's in total. So the most you could win is, well, so the first pile would start out at 20p, right? So it'd be 20p, 40p, 80p, 160, 320, 640. At that point, that would
How many rounds?
be it. So £6.40, I think, is the most you could win. So it's not so many rounds, 6 rounds. I shouldn't tell you these things because last time people made mistakes because they couldn't count. I need you to make as many mistakes as possible, otherwise I'm going to be broke. Okay, so he'll start the bidding at 5p. You're guaranteed to make 5p. Pardon? The person who's bid the most. So someone will give me 5p to play.
Yeah.
Yeah, okay. 10p. Yeah. 15.
Yeah.
Okay, 20. Do I hear 20? Yeah, I hear 20 at the front. You're out 25p. Will anyone give me 25p?
That's why I'm not feeling, I don't know how.
Okay, so clearly your plans to coordinate, or maybe they're working too well and you intend to split all the profits. 25p someone.
No, I've taken my bid out, just to clarify. I've taken my bid out, I'm not no longer bidding.
Okay, so no one will give me 25p, really? Disappointed in you all. Okay, so we'll have an initial game, let's see how that happens. So who bid 15p?
That was me, but I've taken it out, because I'm not bidding that anymore.
Okay, who will pay 5p to go second?
4p.
You get 5p! Well, clearly you don't trust each other. Okay, who's going second? 5p?
Yeah.
Okay, good. We've got someone. No one will pay me 10p, I suppose. Okay, so we've got our 2 players. Okay, so are you going to take the money or are you going to pass it to your friend over there?
Yeah.
Should I take it?
Okay, well that was. Well, you don't get the last one. You get the 4. You get the 4. Okay, but you paid me 20p to play, didn't you? So in fact, In fact, nothing really happened there. You're all too rational. I was expecting you to collude, you know, you were all having a little chat while I was away. Well, you pay, so he paid 5p to play and then got 5p back. You paid 20p to play and got 20p back. So you're the model of economic rationality, which is very boring, really. Should we have another go?
How do you play?
Pardon?
How do you play?
So, you know, okay, so we start with one pile with 4, one pile with 5, with 1. Okay, if you choose not to take the money, then the 2 piles go across the table, and I double each pile. Okay, so if you choose to be patient, you can get, next time it comes back, so the other person then has a choice between getting 10p and getting 40p. Okay, if they're patient, they push it back to you, then you have a choice of getting 20p or 80p. Okay, it keeps on doubling. 2, 3, 4. So the more patient people are, the more money there is worth. Should we have another go? You want to play now?
Do you accept card?
Well, you can pay me out of your winnings. It's fine.
I'm joking. I still don't get it.
Out of your winnings.
Out of your winnings.
Out of your winnings.
Yeah. Okay. Well, will someone pay me? You'll play.
Yeah.
Okay. I'm not sure I trust you. So, how much?
I'll pay 20p.
You'll pay 20p to go first.
I'll pay 15.
You'll pay 50.
15.
15.
Let's go second.
To go second.
Okay. Okay. I'll take that. There's some potential with some collusion there. Okay. So let's. Anyone want to beat their bids? We've got 20p to go first and 15p to go second.
Can I just clarify? We keep the money.
You keep the money, yeah. I'm just giving away my money to you two as your friends. No one wants to outbid them? Your last opportunity to rid me of my money. Okay, so you two are playing. Okay, so you're going first, you said. Okay. You think you can trust each other, do you? Okay. You're going to take the money or you're going to push it across? Okay. You trust him to push it back, do you?
I don't know.
Okay, this is going to be expensive. Expensive is at least more interesting. Okay, so I've got to double these. So you missed up the opportunity to rid me of my money. You have to do 2, 3, 4. 1, 2, 3, 4. Okay. You're going to take the money. You're going to push. Okay, you're very trusting.
Maybe we keep it in the middle.
Okay. Okay, so I've got to double those. What do we got? 1, 2, 3, 4. 4, 2. Keep it in piles of 4. So. 1, 2, 3, 4. Okay. 3, 4. You really going to trust them to give you... I don't know. Okay. You're very trusting in each other. Okay. I think you're basically taking all my money. Right? I should have got larger denominations. Okay. Excuse me. 2, 3, 4. Okay, that's an 8. 2, 3, 4, 5. 6, 8.
As you keep your fingers like that.
At this point, I'm making a loss. That's clear. 1, 2, 3, 4, 5, 6, 7, 8. Are they all of them? I think so. Sure you don't want to take that lovely pile of money?
No, I'll push it.
You start counting these piles, I'll do these piles, okay? So, you know, kind of duplicate those ones. So these should be 16.
Just split.
1, 2, 3, 4, 5,
Can you imagine like
Might as well just do that one.
I think this must be the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Huh?
12, 18,
5 piece now.
16. Okay, and clearly I can't push again, so that's the end of the game. Therefore, these are yours. And these are yours.
I feel really bad.
It's
Do you
fine.
actually keep it?
Yeah. Put it in the, have a coin bag. Oh, you owe me, what did you say? 15p.
Oh, 15,
paid,
yeah.
And you owe me 20p.
I also
Okay.
owe you 15.
That's true.
No, actually, I owe you 20.
Okay, so that was your deal that you'd pay each other's entry costs. Okay, so you know, aside from being a way of robbing me blind, it's a good example of, you know, sort of relevant bits of game theory from industrial organisation. Okay, so the two of them clearly had some kind of collusive agreement in order to sustain this non-subgame perfect Nash equilibrium. And collusion is something you do see between firms, and we'll look at collusion a bit later on. The outcome of collusion is that they made high profits. So collusion can be a good thing, but at the same time, it's quite a risky thing, right? You know, in the end, sorry, I don't know your respective names. Octavia. So in the end, Octavia made all the money because she was playing in the final round. Jamie would have been a lot better if they'd taken the money in the previous round. So, you know, Jamie had very strong incentives to deviate from their collusive agreement that round. And maybe he didn't because there's some reputation built up between the two of them, and you know, there's some longer game that they're playing between the two of them. So these are the same things that you see in collusion between firms. So collusion can be quite a fragile thing, and people have very strong incentives to deviate. You know, so what was the rational thing to do in that game? Well, the rational thing was exactly what we saw in the first round, that you take the money immediately. Okay, so you two are very rational. Also doesn't make for good entertainment, but economics is really very entertaining. Okay, so the rational thing is just to take the money, but maybe you can collude, as those two do, to get a bit more. And why is that? Well, just think about the penultimate period, right? It was your go, Jamie's go. You had a choice between getting, so it must be £6.40, £3.20, £1.60. You had a choice between getting, no, it would have been £3.20. You could have got £3.20 then, or by pushing, you ended up with £1.60. So by pushing across, he essentially threw away £1.60. If he'd been a bastard that period and just taken the money, he would have got £1.60 more than he ended up with. And then if he was going to be a bastard that period, the previous period, Octavia would have been better, taking, what would it have been, £1.60 rather than okay, and then if Jamie, sorry?
Is it operator optimal for me to push it? So between two of us we made more than we would have.
Yeah, so it maximizes total welfare, but at the same time you've got this individual incentive to take the money. It's a bit like the prisoner's dilemma, right? In the prisoner's dilemma, the cooperate gives everyone the highest total welfare, but it's a strictly dominant strategy to defect, to screw the other person over. And here too, it's a strictly dominant strategy to take the money, to screw over the other person. So these things unwind, okay? If one person was going to take the money in the previous period, then in the period before that, the other person should take the money. Then given that, the period before that, that person should take the money. So the period before that, that person should take the money, and so on. Okay, so you start by working out what happens at the end of the game, and then you run backwards in time, and you can work out what should happen in every period of the game. And what you find with this game, you run backwards, you find that people should take the money in the first period, okay, which is what we saw when we played it the first time. Okay, so we're going to see some multi-period oligopoly games. We're not going to get to collusion today. Collusion we'll get to next week, but we're going to look at some games with entry. Okay, so firms decide in the first period whether or not they're going to enter the industry. If they pay the cost of entry, in the second period they get to compete. And in the second game, we'll look at two types of competition. We'll look at corner competition in the second period, and we'll look at Burton competition in the second period. And the way we solve this is just the same as the way we solved the centipede game, the one they just played. We start in the last period, okay? So we start by working out what happens in the final period, and then given that, we work out what should happen in the first period. So let's start with Burton competition, because it's nice and easy. Okay, so Burton competition, suppose everyone has identical marginal costs. Okay, in the production period, what's going to happen? Well, if there's more than one firm, price will equal marginal cost. Okay, assuming pure strategy equilibria. If there's only one firm, then you get the monopoly level of profits. Okay, so let's say that the monopoly level of profits are pi m star. It's just, we don't want to have to work out what they are, let's just call them pi m star. And let's suppose that entering the industry costs capital F, okay, where monopoly profits are bigger than cost of entering the industry. Okay, so if, I talk about monopoly profits, this is monopoly profits not including the entry cost. This is kind of monopoly profits from the production period only. Okay. So if one firm enters, they get a total revenue of pi m star minus F, total profits of pi m star minus F. This is bigger than that, so they're happy, they make positive profits. If two firms enter, well then in the second period, price is equal to marginal cost, so they all make zero profit. Okay, so then they've just, have I got this on the slide somewhere? They just make profit equal to minus F. Okay, so they make a strict loss. So if one firm enters, that firm makes a profit. If two firms enter, they all make a loss. Likewise, if three firms enter, they all make a loss. So what's going to happen in equilibrium? Well, only one firm is going to enter, right? Somehow the firms decide between them which one is going to enter, and just one firm enters. So with Burton competition, what you get is monopoly. So Burton competition leads to the monopoly outcome, because firms don't want to compete in Burton competition. They'd rather just not enter the industry at all. So when there's price competition, when firms are competing in prices, we should expect to see the monopoly outcome. So it's not that price competition is a good thing, price competition is a bad thing because it leads to only one firm entering the industry. And I say on the board, okay, I was with if you've got lots of different potential entrants, all with different marginal costs, which one is going to enter? Yeah, exactly. Because if two, suppose someone with high marginal cost was going to enter, then someone with low marginal cost would also like to enter, because they can still make profits because they've got lower marginal cost from the other firm. Okay. So this second firm with lower marginal cost, they would like to enter even if a high marginal cost was going to enter. But then the firm with high marginal cost is making zero profits, so they would have been better off not entering at all. So they're not going to enter, only the firm with the lowest marginal cost is going to enter. So, that's a kind of good thing about virgin competition, that it encourages only firms with low marginal cost to enter, but we're still getting all of these monopoly distortions, okay? We're still getting deadweight loss because of monopoly. So maybe the government should subsidize entry costs to encourage a better competition in these industries. So when should the government do this? When does it make sense for the government to pay the entry cost? Simple calculation will tell you that it should do it. The government should pay the entry. Excuse me, dying. It should pay the entry cost when the deadweight loss due to monopoly is greater than F. Okay, if you think about what happens when you have a second firm enter, well, if you've only got one firm in the industry, your inefficiency cost is the entry cost and the deadweight loss. If you have two firms in the industry, then you've got two entry costs, but you don't have a deadweight loss. Okay, so the gain in social welfare is the deadweight loss minus the entry cost. Okay, so as long as the deadweight loss is higher than the entry cost, then it makes sense to subsidize another firm to enter the industry. This is just the formula for deadweight loss. Okay, so in some circumstances, the government should pay another firm to enter the industry. And the exercise is just kind of working through this in a particular case of linear demand. A little bit boring. So what about with Corno competition? Well, Corno competition, so again the same setup. First period, firms decide whether or not to enter. Those that enter pay an entry cost. Second period, they compete in quantities, so like Corno competition. And we're going to do it with isoelastic demand, just like we saw. And we're going to assume that all firms have the same marginal cost. Okay. So they have some marginal cost, say. Well, what we showed earlier on, okay, was that they're going to set a price of C over 1 minus beta over N. That's what we showed on the board before the break. This we didn't show, so let's just derive that because we didn't show it earlier. So we know that we've got two expressions for P, right? We've got P is KQ to minus beta, and we've got P is C over 1 minus beta over N. Okay, so if we equate the two things, we can solve for capital Q. So what do we have? We have KQ to minus beta is equal to C over 1 minus beta over N. And we want to solve for Q. So let's divide by, excuse me, let's divide by K. So Q to minus beta is C divided by K minus beta K divided by N. Okay, just divided by size by K. And let's simplify this a bit. So let's multiply top and bottom of this fraction by N. So this is Cn divided by Kn minus beta K. Okay, so now we've got Q to minus beta here. So let's raise both sides to the power of minus 1. Okay, so then this becomes Q to the power of beta equals Raising this to the minus 1 is just the same as flipping the fraction. So kn minus beta k divided by cn. So q equals all of this, kn minus beta k divided by cn, all to the power of 1 over beta. So what I have on the board, kn minus beta k divided by cn. Okay, so that's the quantity that gets produced under Cournot competition. Okay, so we've got a price, we've got a quantity. Now we can work out profits. Okay, it's just tedious algebra. So we've got profits, price minus marginal, excluding the fixed cost for now. Profits are price minus marginal cost times individual quantity. Well, all these terms are the same. What's the individual quantity? It's total quantity divided by n. Okay, we've got n firms. So in total, they're producing Q. So each firm is producing Q divided by n. Okay, so price minus cost times individual quantity. Well, substitute in for price. So here's price, C over 1 minus beta over n minus C times Q over n. So what have I done? So I've substituted in for Q now. Q is this thing. So that's over here. The divided by n I put in the front, 1 over n. And then I just rearrange this term in square brackets. Let's just do that. Oh God. So the term in square brackets is, well, first let's multiply top and bottom by n. So it's Cn over 1 over n minus beta, all minus c. Well, that's equal to Cn over n minus beta minus n minus beta over n minus beta. Okay, sorry, all times c. Cn minus c beta. Is that clear? C is just equal to Cn minus beta c over n minus beta, because the n minus betas cancel. Okay, so this is Cn minus Cn, those are going to cancel out. Minus minus makes a plus, so it's beta c over n minus beta. Which is hopefully what I've got. Yeah, beta c over n minus beta. Okay, so these are the profits firms make in the production period under Cournot competition. So how many firms are going to enter in the first period? Well, they're going to enter as long as the cost of entry is less than the profits they make from entering. Make sense, right? So they're going to carry on entering while this thing is bigger than F. So the number of firms that enter is going to be the largest integer such that profits are bigger than F. Okay, as the number of firms enters, profits are going to decrease. Okay, eventually profits are going to be less than the cost of entry. So the number of firms that enter is going to be the maximum number that can enter such that this thing is still bigger than that. Does that make sense? The firms carry on entering until a point where if another firm entered, that firm would make negative profits. And obviously this is a horrible inequality, it's not very nice to deal with. So approximately what's going to happen is firms are going to carry on entering until profits are equal to the fixed cost. Okay, so at least approximately profits will end up equal to the fixed cost. So if you like, you can think about, imagine that a fractional number of firms entered. Okay, imagine that 7.2 firms entered. There's going to be some number such that this thing is equal to this thing. Okay, so maybe 7.2 firms enter. Well, obviously 7.2 firms can't enter, but it makes the maths easier if we think as if they could. Okay. So approximately profits which is this term, is going to be equal to the entry cost. So the n that solves this equation, that's going to be the number of firms that enter the Corning competition. Okay, so this is a slightly messy equation, but still we can think a bit about what's going to happen to the number of firms in the industry as other things change. Okay, so remember that we had this demand curve, inverse demand curve, P equals KQ to the minus beta. Okay, so P over K equals Q to minus beta, or K over P equals Q to the beta. Okay, so Q equals K over P all to the power of 1 over beta. So that's the demand curve. I'm just inverting the demand curve. Okay, so this is our inverse demand curve, this is the demand curve. So what's K measuring? So if you like, this is K to the power of 1 over beta times P to the power of minus 1 over beta. So K to the power of 1 over beta, that's a measure of the size of the market. This is K to 1 over beta, P to the minus 1. So why do I say this is the size of a market, K to 1 over beta? Because if you double this, you double quantity at any price. Okay, so this thing, K to the 1 over beta, this is kind of scaling the whole size of the market. So, maybe this is like population or something. If you double population, you would expect this thing to double. You would expect demand to be twice as high at any price. Okay, so if K to the power of 1 over beta doubles, then demand doubles at any price. That's what I'm saying. So let's look at this entry condition. We've got a 1 over n here, and we've got an f here. So that we can take the n over here, and we can take the f over there. And then inside this brackets, right, we've got a k here, we've got a k here. So we can take k out of this brackets. This is like k to the power of 1 over beta times n minus beta over cn, all to the power of 1 over beta. Okay, so we can take a k to the power of 1 over beta out, we can take it over to the other side. Okay, so n divided by k to 1 over beta is approximately equal to this thing. Okay, all I've done is divided by f multiplied by n divided by k to 1 over beta. It's just rearranged from the previous equation. Okay, so k to 1 over beta is the size of the market. You might expect that the number of firms would grow proportionally to the size of the market. Okay, if the market was twice as big, you might think there would be twice as many firms. Okay, well, if that was the case, then this ratio of the number of firms to the size of the market, that ought to be roughly constant. Okay, but, well, what have we got over here? It doesn't look like it's going to be constant. We've got, we've got an n on the top, we've got an n on the bottom. Okay, so when n is big, this is going to be, approximately constant. This is going to tend to something as n gets big. Okay, so this term isn't going to affect things much with big N, but this one is, right? We've got an n on the bottom. So when n is big, this thing is going to be small. Okay, so when n is big, the number of firms divided by the size of a market is going to be small. So when we're a large number of firms, we're actually going to be fewer than you would expect. Does that make sense? Or equivalently, when the market is big, there would be fewer firms than you would expect there to be. So Corner competition says we should expect firms to be bigger in larger markets. Okay, when you know, if you compare the US and the UK, if firms are competing in core no competition, then you should expect, you know, maybe the US is 4 times a bigger market than the UK. You shouldn't expect there to be 4 times as many firms. There should be fewer than 4 times as many firms, and the firms in the US should be bigger than the firms in the UK. So that's quite a clear prediction that we can test. Okay, so it's a nice testable prediction of core no competition. And what's driving that? Well, suppose the price didn't adjust at all. Okay, suppose if another firm entered, the price stayed the same. Well, then the number of firms would scale. Okay, because the price is staying the same, so you know profits are just kind of scaling proportionally as more firms enter. So then you know then you keep the number of firms would be proportional to the size of the market. Okay, but in fact what happens is when another firm enters, well, that increases competition, it kind of reduces markups, it has an effect on all of the other firms. Every firm ends up selling a lower price after another firm enters. Okay, so each entering firm is not internalizing its effects on the other firms in the market. So firms are exerting externality, if you like, on the other firms in the market. So this means that you end up with I'm getting ahead of myself a bit. So as each firm enters, the price gets lower. That makes it even less tempting for new firms to enter. Okay, new firms entering, they reduce the price. They mean that it's less tempting for the next firm to enter. Okay, so to encourage the next firm to enter, the market has to be that much bigger. Does that make sense? You know, think about a gradually growing market. Okay, you know, there's one firm in, second firm enters quite happily, but then the price is a bit lower. Okay, so then it's harder to persuade the third firm to enter. You need an even bigger market. And then price is even lower. So to persuade a fourth firm to enter, you need an even more bigger market. Okay, so firms are going to be larger in these larger markets. And this is a general property of core no. It's not specific to isoelastic. So this is something that's been tested quite a bit. So these guys, Campbell and Hoffenheim, they regressed average firm size in an industry on the number of firms. Okay, so they're testing whether or not there's a proportional link between the number of firms and whether the number of firms has any effect on firm size. Okay, if firms were always the same size, regardless of the size of the market, you'd expect there to be no link between firm size and the number of firms. Okay, but what they find is when there are lots of firms in an industry, then also those firms tend to be bigger. Okay, so this is consistent with core no competition. Industries with lots of firms tend to have generally bigger firms. So industries with lots of firms, well, they happen when you've got very high demand and you get bigger firms in both industries. So this is consistent with the model. And then Bresnahan and Rice do something a bit more sophisticated. They're looking at the market size required to support a certain number of firms. Okay, so suppose we call the market size that's required to support n firms Sn. Okay, if a market size required to support a number of firms was proportional to the number of firms, then we would get that Sn plus 1 over Sn would be equal to n plus 1 over n. Okay? So, you know, if the intuitive thing was true, okay, in which if you double the market size, you double the number of firms, then Sn would just be proportional to n. Okay, so Sn plus 1 over Sn would be equal to n plus 1 over n. Let me just write it another way. Suppose that the number of firms required to support, suppose that the size of a market required to support n firms was, I don't know, alpha times n, just some constant times n. Okay, then Sn plus 1 divided by Sn is alpha times n plus 1 divided by alpha times n, which is n plus 1 over n. Okay. But, Corno competition says this isn't true. Under Corno competition, what we get is that Sn is, it's kind of increasing. So, we get something more like that, but you need a, well, that's fine. So on the corner competition, this thing isn't true. Okay, it's not proportional. Okay, instead it's exponential. It's more like maybe it's Sn is n to the power of 1 plus kappa. So okay, maybe it's something like that, or alpha times n to the power of 1 plus kappa. Then when we do Sn plus 1 divided by Sn, what do we get? Well, we get the alphas are going to cancel out again. Okay, we get n plus 1 to the power of 1 plus kappa divided by, I think this is a nice way. One second, let me do this in a better way. Alpha e, suppose it was something like this, e to the power of kappa times n. Okay, I'm just doing this for illustration so you can see why what they're testing makes sense. Okay, so under corner, let me go back a bit. So under corner competition, we found it wasn't the case that the size of a market needed to support n firms was just proportional to the number of firms. Okay, that's not true. What we found was that you needed a larger market to support, a proportionally larger market to support more firms. Okay, so it's like for the size of a market you need to support n firms was kind of growing exponentially in the number of firms. So here we've got, suppose the size of the market was alpha e to the kn. Okay, so it's growing exponentially. Then what's this ratio, Sn plus 1 over Sn? The alphas cancel, it's e to the kappa n plus 1, all divided by e to the kappa n, okay, which is, these things are going to cancel out, is that good enough? Okay, yeah, okay, so this is a constant. Okay, and in particular, here we found Sn plus 1 over Sm was equal to n plus 1 over n. When n is big, this is approximately 1. Okay, whereas when n is big, this is still bigger than 1. Okay, this is just some constant, it's bigger than 1. It's not tending to 1 as the number of firms goes to 1. I'm not sure if that's helpful. Okay, so what Buchanan and Rice test is this thing. So they test if Sn plus the size of the market needed to support n plus 1 firms divided by the size of the market needed to support n firms. They test if that is bigger than n plus 1 over n. Okay? If the size of the market was just proportional, then this would not be true. Okay? It would be an equal sign, not a greater than. Under Corno competition, it is true. Okay? Because firms are bigger in larger markets. So as the size of the market increases, to support n plus 1 firms, you need just that much bigger market. Okay, is that clear? Approximately.
Sorry, does that mean, for example, if there is a new car entrant,
Yeah.
and Ford has to make its size bigger, Is that true, according to this?
So there would only be a new entrant if the market had increased, right? So suppose that so China comes into the world market. Okay, that's a big increase in size of the demand for cars, right? Before, people in the developing world, China and India, they weren't buying cars. Now people in China and India want to buy cars. So there's been a big increase in the size of the market. So yeah, maybe we should expect new entrants, but we should also expect the existing firms to get bigger. Okay, so yeah, we should expect that Ford and GM will be bigger than they were before. Yeah, it's a bit confusing because it has to be something else that's driving all of these changes. It's not that new firms are entering and that's changing the size of other firms. It's that the size of a market or entry costs or something about demand is changing, and that's driving both the size of firms and how many firms there are. Okay, but what we have for corner competition is that firms tend to be bigger when there are lots of firms. Okay. Because of what I said here, as markets get larger, more firms enter, prices fall. That makes it less tempting for new firms to enter. Okay, so the number of firms grows less than proportionally with the size of the market. So according to corner competition, we should have this thing: Sn plus 1 over Sn is bigger than n plus 1 over n. And what they find is that this holds for small n. So as you go from one firm to two firms, the size of a market has to more than double. As you go from two firms to three firms, the size of a market has to increase by more than 50%. As you go from three firms to four firms, the size of a market has to increase by more than 33%. Okay, but as you go from, what they find is that as you go from four firms to five firms, then it doesn't make the size of the market can just grow by 20%. That's enough. Okay, so the corner prediction only seems to work when there are few firms. When there are lots of firms, it looks like the size of a market grows. The size of the market you need to support that number of firms grows proportional to the number of firms. Okay, so corner competition seems to do well when there are few firms, not very well when there are lots of firms. Okay, so what might be going on? Well, one explanation is that corner competition is capturing the fact that as you increase the number of firms, prices get pushed down. Okay, but this result suggests that once you have at least four firms, prices are basically as pushed down as they're ever going to be. So according to this result, four firms is kind of enough to get as much competition as you're ever going to get. Prices don't go down anymore, it seems, and thus if prices are staying the same, then the size of a market needed to support a certain number of firms is just proportional to the number of firms. And yeah, I'm not going to get through welfare today, so why don't we stop there a bit early? Okay, and we'll do welfare next week. Okay, you've got some exercises. There was an exercise on the slide. There was the corner one from the previous topic, and and there's some corner exercises here as well. Okay, so don't worry about the social welfare bits, we'll do welfare next week. Okay, but do this, work out the number of firms that enter. Do this first bit at least. And likewise, do these bits. Okay, so do this and do that. There you go. And I expect this one's probably doable as well.
You put the wrong thing on this.
Okay. Any questions?
Anymore? Why? Because
See you tomorrow.
I'm in London.